I'm Ben Wilton and this is my HNC Electrical project, and my project is based on Maintenance and Reliability Unit 4. So the introduction to the project is, to summarise my project, is to improve the reliability of the UPS and the battery chargers across the Akumi complex. So that's Alpha, Bravo, Charlie, lots of satellite platforms, all connected to Charlie platform, so it goes up to Fox platform. So each platform has as many UPSs and battery chargers. The idea is to do a planned change out of the chargers in 2025-26 capex, but recently, due to the changes in the budget, we're now delivering only 6 critical chargers, and then doing that under the maintenance funding instead of capex. So Akumi complex, everything has 32 UPS battery chargers across its assets and in service since 2005. So these backup systems are critical to the reliability of the 24 volt and 124 volt systems, and consumers controlling the process and safety systems. So the aim of this project is to improve the reliability of the chargers, to look at the batteries, look at the battery chargers themselves and see what's been failing, the main component failures, and potentially reducing the battery cell failures, and to prioritise what autonomy we can have in each charger. So the survey, the cost, and what would be priority. And like I said before, the budget's been removed, so we just have to concentrate on the main chargers. And here's just a picture of the driver board for one of the chargers, which is built for that charger. So it's when it becomes obsolete, these boards become unavailable. So that's one of the reasons why we change. Background and problem statement. So again, the chargers and the voltages, aging units, 20 years old. So the autonomy loss and the charger parts obsolescence, and high risk to process and control safety systems. These chargers do feed all of the control systems, so one failure on a charger trips the control system and you have complete production loss and blackout on the platform. Many are now obsolete and the autonomy has dropped below the original design levels. You see the old charger here, 24 volt system. These are master and slave systems, so you have 2 battery chargers charging one battery bank, and that battery bank on a bus connected to its 24 volt consumers. So the survey is to record all of the condition of the 32 chargers, look at replace or refurbishment options, and develop a plan for reliability of improvement. And realistically, that plan's going to change now because of the budget. The key points, the average autonomy that we've checked so far is about 7 hours. 7 systems classified good. Common failure modes are the battery degradation, the charger board faults, I showed a picture of that, and the fans, capacitors as well, which isn't on here. So this declines the autonomy, declines the battery life, and reduces the overall reliability. So the key findings here is we have actually replaced some chargers in the blue. The green here is chargers that we found that they've pre-purchased some and they're just sat in the warehouse for many years. So we just change the capacitors and we can install them. This 30% was the finding of the ones that we're going to replace, and this blue is the ones to replace in the future. So here's the feasibility footprint of 90k for 6 chargers, but it's 25k for a dual charger, which is 2 chargers in one. So it does reduce the cost. So it looks like it's 2 chargers, but it's 1. Legally compliant, and we won't be using master and slave. We'll be using dual to save the footprint. 6-month execution window is achievable because we found some chargers on SAP which are in the warehouse already. it's just a repeat there really. Tools, so we'll have a Gantt chart for planning, a survey analysis, which is pretty much finished and ongoing now, ongoing and finished. The E&I team, maybe the vendor FSR, possibly during the commissioning stage, but we'll try to do it without. Depends if it needs a commissioning password or not. Weekly progress calls and milestone reviews. We don't really do the weekly calls specifically for this one job, but we'll do the weekly calls, and this will be included in the weekly call. So instead of the 221k capex pays proposal, that we replaced by maintenance. The cost is actually wrong there for all charges. That's just looking at the 6. Like I say, 6, it says 3, it's joules. So what could be the risk is the permits and access delays. So it could be another job, sim ops going on at the same time that takes them people away from this job, puts them on another job instead. DC isolation risk, so if they work on the secondary string, it should be a charger, secondary charger first, they can keep the supply onto the consumers, and then they can put the secondary charger on after and then take the primary away. So they can do it in stages and keep the consumers live without shutdown. If you get vendors, there's normally delays in visas and the costing involved in that. And then there's the battery acid hazard. That's not so much a problem because we've moved all the batteries into one cool room and we're not actually touching the batteries. Batteries have been assessed, but we're only touching the chargers. So most risks are you can mitigate with good practices. So I put 6 critical chargers to install in the maintenance funding. 6 is 3. Legacy units retained as emergency spares. So when we take a unit out, we can keep that unit as a spare unit for the others. So it's not going in the bin until everything's been replaced. And then we'll just condition trend the improvements by the cell corder test. So that's testing the batteries' resistance cells to see if they last longer. And then the next phase, 2027, will ask for centralised battery monitoring. I'd imagine that would be 2028 now, and 2027 will be the request again for more funds. So this is the main steps to maintain the reliability above 99.8, but it's easy to do that because you've got a dual charger. If one falls over, the other still remains charging. So we can quite easily do that. So we'll have to improve the project management and cost realism because we don't have the budget. Balanced reliability versus the budget restraints. This means that we'll probably do the process safety system and process control system only, and maybe the public address system. Stronger collaboration between maintenance and finance. This is the problem really with the budget. The budget was made and given, and finance has just cut parts of the budget without realising the importance of it, financing other tasks which shouldn't have been done, and keep the trend in. So we'll do a 6 monthly check on the batteries and the chargers and keep that trending in SAP. So this project's basically taught me about reliability and the financial scheduling and adapting budgets, and it was the key to learning really is we had some faults during this, and the order was put into place before we'd finished our plan, so that changed as well. So when we reflect on it, we had some failures during this project, so we jumped ahead with some of the orders, and that's it. That's the end of that. So do you have any questions?
Yes, please. When do the batteries get replaced?
So the batteries at the moment last about 6 years. They should last 10. And we check them with the cell corder, and when the resistance gets to 50% of the original resistance, then we put an order in and then it takes about a year for the batteries to come into country, and then they're replaced. So we wait for the baseline to get to 50%, and then we're replaced. So we're hoping with the new chargers we get, and the new environment, we get about 10 years out of them.
Okay, thank you. Also, if 6 chargers get replaced in 2025, how many will remain to be replaced?
So we'll have 6 chargers we've already replaced, or we've already got 10 actually replaced. So we're going to be halfway after this project, and we'll have the other 16 chargers to replace in the future years. But they are, I wouldn't say not urgent, but they're chargers for utility or for foghorn or for navigation lights. They have international standards for being at sea, but actually in Equatorial Guinea not. But we still have them because we don't want to take them away. So they're deemed less critical than process.
Okay, thank you. And just finally, centralised battery monitoring, what will it mean?
So the new battery chargers will have a RJ45 Ethernet port, and that information will come back to a central computer, and the software on the central computer will analyse all of the batteries. So if we have a fault on a charger, it will come in, or we can put it into the DCS system itself and have it configured so the battery alarms and alerts come into our system. So instead of having a physical check, we'll still do the physical checks, but we'll have annunciation on our control system which will say battery charger fault. Maybe it's under voltage or temperature, or cell has dropped. So we'll just have a smarter monitoring system than somebody going around checking with a cell recorder every 6 months.
Oh, brilliant. Yeah, that's it. Thank you very
Okay,
much.
thank you.